Hi all. Let's start with the second part of fifth unit, multiprocessors. The first topic is the characteristics of multiprocessors. So in this lecture, we are going to say about an introduction to what is a multiprocessor system and what are the characteristics of the multiprocessor system. Coming to the introduction, multiprocessor, as the name implies, multiprocessor is nothing but it is a set of processors which are connected by means of a communication network. So a system consists of a set of processors or CPUs which are connected by means of a communication network. Or we can also say as a multiprocessor system is an interconnection of two or more CPUs along with its memory and input output equipments which are connected through a communication network. So multiprocessor systems are classified as MIMD architectures. So, when we talked about Flynn's taxonomy, we come across different types of architectures called as single instruction, single data stream, single instruction, multiple data stream, multi-instruction, single data stream, and multi-instruction, multiple data streams. So, this multiprocessor architecture implements the concept of multi-instruction, multiple data stream. So there exists a distinction between the multiprocessor systems and multi-computers. Even though both of them support the concurrent operations, there is a difference between the multiprocessor systems and the multi-computers. So if you consider a multi-computer system, you will have several autonomous computers, separate computers, which are connected through a network and they may or may not communicate. They can communicate or they may not communicate. If they want to communicate, they communicate through a network. But in case of a multiprocessor system, there will be a single operating system which has a control over all the CPUs which are provided in the particular system, and it provides an interaction between the multiple processors and all the components of the system in order to provide solutions to the problems. So a multi-processor system contains multiple processors present within a single computer system and which is controlled by a single operating system. So with the advancement of VLSI circuit technology, it reduced the cost of the computers to such a level that the concept of applying multiple processors in order to meet the system performance, which becomes an attractive design. So the main aim of designing a multiprocessor system is to implement or achieve high performance by providing multiple tasks within a single computer system at the same point of time so as to improve the performance of your system. So if you see the architecture of a basic multiprocessor system, you have multiple CPUs or the processors which are connected by means of an interprocessor communication network. So that processor can communicate among themselves in order to complete a given task, or they can share the resources among themselves. So this is the idea behind the multiprocessor architecture. About the organization of a processor, we already know that we have a serial communication and a parallel communication. So SISD, single instruction, single data stream, implements the concept of serial communication, where only one task can be completed at a point of time. And the examples of the processors that implement the SISD concept is a uniprocessor system. There where they have a single processor or a CPU present in a computer system which is capable of doing only one task at a time. But compared to a concept of parallel processing environment, when it comes to a concept of parallel processing environment, there is multiple possibilities like SIMD, MISD, and MIMD. When it comes to SIMD, single instruction multiple data stream, it can be implemented by these vector processors or array processors. When you want to perform execution on a single instruction or multiple sets of data, then you can go for the concept of vector processors or array processors. And when you come with if you want the concept of multi-instruction multiple data stream, that is implemented by means of a multiprocessor systems. So again, there are two types of multiprocessor systems like a tightly coupled systems and loosely coupled systems. Let us see. So next, coming to the characteristics of a multiprocessor system. So multiprocessing, it increases the reliability of your system. So because you have multiple processors or multiple CPUs present in a single computer system, so that if there is any error or any failure in one part of the system or one CPU, it will have the effect only to that particular part of your system, and the rest of the system it functions in a normal way. If for example, if a processor fails or if there is any fault in any one of the processor, then the remaining processors can be assigned to perform the functions of the faulty processor. So they'll say, for example, in my system, I have five CPUs where one CPU is failed due to some reason. So the remaining four CPUs will share the work of this particular CPU in order to make the smooth functioning of your system. So that is reliability of your system. Next, it improves the system performance. So system derives from high performance from the fact that when you have multiple CPUs present, you can perform multiple computations in parallel. You can give multiple independent jobs to multiple CPUs in parallel, or a single job can be partitioned into parallel tasks and it can be assigned to multiple CPUs at a time. It can be done in both the ways. So the concept of parallelism or parallel processing can be improved so that it improves the performance of your computer system. Next, how can you implement the concept of parallelism? It can be achieved in two ways. The user can explicitly declare the task of program that can be executed in parallel, or the compiler, which is provided multiprocessors, it can automatically detect the parallelism in your program and assign the task to your multiple CPUs. So next, coming to the other characteristic of a multiprocessor system is your coupling. So what do you mean by coupling? So coupling is nothing but it is the degree of interaction among the processors. It defines about the degree of interaction among the processor and interdependence between the individual processors which are present in the system. What do you mean by degree of interaction? It means that how the processors share the resources, how the processors can communicate with each other, all these is said to be called as a degree of interaction. Processors are classified by the way their memory is organized and how the processors share the resources, how they communicate with each other. Based on that, they are divided into two types: loosely coupled systems and tightly coupled systems. So, a multiprocessor system with a common shared memory, we call it as a tightly coupled multiprocessor system. They have all the processors present in the system, they share a common memory in order to communicate each other. So, that type of system is said to be called as a tightly coupled multiprocessor system, or we can also call it as a shared tightly coupled memory. So tightly coupled multiprocessors, they have the cache memory, a provided cache memory with each CPU. In addition, there will be a global common memory that all the CPUs can access. So when there are multiple processors present in the system, each processor itself has its own cache memory and all the processors share a common global memory. So the information can be shared among multiple CPUs by placing it into the global memory. Next type of multiprocessor systems are said to be called as a loosely coupled systems or distributed memory. So here each processor element has its own private local memory, and the processors within the system are tied together by a switching scheme. So which is designed in order to route your information from one processor to another processor, and we call this switching scheme as message passing scheme. So by implementing the concept of message passing, here we don't have any shared memory, so that the processors can communicate with each other with the help of a shared memory. That is done in the case of a shared memory system or tightly coupled system. Since here we don't have any shared memory present, the information or the communication between the processors can be done with the help of a scheme called as a message passing scheme. So the message passing packets, it consists of an address, the data content, and some error detection code. With the help of these packets, the communication will take place between the processors. And there is an overhead because of this particular technique, which in case of data exchange. So when the information has to be passed from one processor to another, there is a certain overhead that is occurred due to the exchange of information in the form of a message passing packets, and that is high in case of a distributed memory or a loosely coupled system. When you compare this loosely coupled system, they are more efficient when the interaction between the tasks is very minimal. But when you want, whereas in case of a tightly coupled system, they can tolerate high degree of interaction between the tasks. So shared memory, you have a global memory which is accessible by all processors, and processors also have their own local memory. In case of a distributed memory or a message passing model, all the memory units are associated with the processors, and to retrieve the any information from another processor, it takes by means of a message passing. A message must be sent. So the information between the processors is done by means of a message passing concept. This is an example of a shared memory system where memory is shared between all the processors that exist in the system, and these are the processors, and this is the shared part of the memory. So each and every processor is going to share a part of the memory, and they are connected by means of an interconnection network. And any processors can access any part of a shared memory at any point of time. So this is called as shared memory system. And distributed memory, in case of a distributed memory, each process has its own local memory, and they doesn't have any shared memory. So the communication between the process takes place by means of message passing system. So this is the concept of distributed memory. So the multiprocessor system implements the concept of both shared memory and distributed memory depending upon the requirement. So these are the characteristics of multiprocessor systems. Thank you.